Okay. Hello everyone. I am Kanvatia. Yeah. Hello everyone. I am Kanvatia. Kan
And I'm Kanjika Singh, and today we'll be conducting a session on developing an embedding-based custom Q&A bot powered by GPT-3. Throughout this session, we'll be learning about the basics of fine-tuning, semantic search, and we'll compare both the techniques. Then, based on which technique is better, we'll find the use cases and application.
yeah.
So the first technique is fine tuning, which is also called as transfer learning. Here, the new task is being performed. We train the model on the basis of new task, but no new information is given. It is one of the conventional NLP methods, and it is much costlier. I mean, it is around 6 pages per US dollars is what DaVinci costs us. So fine tuning basically is suppose you learn to tie your knot of your shoes. So now you can tie any knot because you have learned how to tie your shoes. You can tie any knot. This is what exactly fine tuning is. You already know some task, but you have to implement it somewhere else. Another example we can have is example of car. So first, the first model on the left hand side is the model which distinguishes between car, motorcycle, and bike. Now this model already knows how to distinguish between the types of vehicle. But now, if I want a certain modification, if I want to identify the number of car brands, what I would do is I would train only the upper layer of the model because already the inner layer understand how to sort the vehicles on the basis of car, motorcycle, or bike. So I just need to freeze the lower layers and I need to perform training applications on the upper layer. So this is how fine tuning works.
Yeah. So now let's move on to semantic search. So semantic search can basically be called vector search because in semantic search we convert our set of text or our sentences or pages into a form of vectors, which are basically a list of floating point numbers, which are also called semantic embeddings. Okay, and once we convert all the text into form of vectors, we can simply compare the vectors to check which of the queries matches with the our vectors, right? So semantic search is more of a context based search. So when we have a given context or a given set of text from which we want our answers from, right? So like it can be anything. It can be code documentation or some guides or anything. So in that case, semantic search using semantic search is much better than fine tuning because fine tuning teaches a new task, as my friend Kanjika said, and semantic search will search from that given context, and moreover it is much cheaper than any other than fine tuning, and it is much easier to. So let's compare fine tuning and semantic search, right? So fine tuning is slow, it is difficult, and it is very expensive. And like let's talk about OpenAI. OpenAI hasn't open sourced how it fine tunes its models. So yeah, so that is basically difficult. While semantic search is much faster, it is easier to implement, and it is much cheaper than fine tuning. And even after fine tuning on our data, the model that we generate, it is still prone to confabulation or hallucination. So, like we taught it a new task, but it still has all the data from its previous tasks, right? So sometimes it produces wrong answers, or basically it can hallucinate while producing its response. While semantic search compares the vectors, finds out the closest vectors, right? So it can recall exact information that we have in our context.
What is
And
meant by hallucinating? Hallucinating, what does it mean here?
okay, so hallucinating basically means that, like, for example, we ask our okay, so we know that ChatGPT has the data till September 2021, right? So if we ask of it for any recent events, it won't say that it doesn't know the answer. It will try to complete our request by saying something random. By completing our request, like from the previous patterns, it has learned from human text or whatever the data is it has been trained on. So that is hallucination. Okay. And yeah, in fine tuning, if we want to add some new data, right? If we like say we fine tune that model on 100 lines of data. Now after using that model, like after using it in production, we have some more data, right? So it is difficult to add that data to the existing model. We have to fine tune it again. But in semantic search, we can just update our vector database and from the new context, and new information will be adding will be very simpler. And fine tuning requires constant retraining with the new data, as I just said, and semantic search is easier. Fine tuning is not scalable because like adding new data is very difficult. So we cannot scale it to large levels where we can constantly add new data and from the different users and everything. But semantic search is infinitely scalable because like we can add any number of vectors to our database and perform a vector search for that. Fine tuning in most cases does not work for Q&A because whatever data we train our model on, it is limited or it it doesn't work. So it can hallucinate, right? So it doesn't work for Q&A. But semantic search recalls exact information, right? So it can work for Q&A for context base. Okay. So moving on to word.
Now we'll move on to word embeddings. Embeddings are basically numerical representation of texts. So basically the model which we'll use is text embedding ADA002. So we have 1536 dimensions for this. We express the text in the form of vectors of a particular number of dimensions. And these are all floating numbers from -1 to 1, all normalized. The degree of closeness can be easily calculated using the word embeddings, which are the representations of the tokens or texts of the words which we have used. Can we move to the next slide? Yeah. So here we see a 2D graph, 2D representation of word embeddings. We can see that Bangalore and Pune, being the places, are closer than the verbs drank or ate. Similarly, lecture and talk are somewhat closely related as compared to Bangalore or Pune or drank or ate. So this 2D representation basically gives us the degree of closeness or the similarity of two particular words. And again, if we talk about Bangalore and Pune and drank and ate, so maybe they are more close as compared to Bangalore and lecture. So this is how text similarity would work. Here we have the representation of each word in the form of embeddings. 0.91, 0.83, these all are floating point values for all the different dimensions, whichever we are taking. If we are considering text embedding ADA002 model, so we'll be considering 1536 dimensions. If it is other models, we'll see the number of dimensions it allows, and we'll have that many number of floating points.
Okay. So different use cases for semantic search would be customer service chatbot, first of all. So say for let's take Amazon. Okay. So Amazon has a lot of products, right? So if we can perform a semantic search on the website, that would be very useful for customer service, right? We can just include a chatbot which can perform semantic search, and the users can ask the chatbot its questions, and yeah, it can perform semantic search and retrieve the results from the whole website, right? And code documentation bot. So say we have a documentation of let's take Python. Python has a huge documentation, and most of the functions, most of the advanced functions are not known to the beginners. So if we combine all the documentation and we convert it to vectors, and we create a chatbot, so the bot will be able to perform vector search based on our queries, and it will give the exact answers and the exact that code whatever we need, right? And legal Q&A bot, this is one of the main use cases of this. So we all know the legal documents are very long and like huge documentations we have, right? So we can again convert it to embeddings, feed it to a bot, and we can ask questions to the bot to extract information from that legal document. And similarly with medical Q&A bot, and we can detect outliers, right? We converted it to vectors, and we can perform a semantic search, and we can see which of our data does not lie in the like in that specific use case that we want, and we can remove the outlying data set. Okay. So
We'll now move on to text embedding ADA002. As mentioned earlier, it combines multiple embedding models. So basically, it merges 5 different models of OpenAI, and it has a context length of 8192 instead of 2048, which means it can process 8192 tokens instead of 2048 at once. Now, this has smaller embedding size. Statistics tell us that it occupies 1/8 of the space as compared to the Da Vinci model. So it is cost effective because it acquires less space. Then it is 99.8% cheaper than Da Vinci. Again, because as per statistics, 3,000 pages per USD is the cost of text embedding AD8002. While if we compare it with Da Vinci, it is about 6 pages per USD.
Somewhere I saw the token limit in GPT or ChatGPT is 4,000 tokens. So this figure shows different, 2,000 versus 8,000.
yes, so this in this slide we're talking about the embedding model, right? So the ADA002 model, it can process 8192 tokens instead of 2048. 2048 was the token length of the first generation of embedding models, right? And that 4092 tokens, 4084 or whatever, around 4,000
Yeah,
tokens that you mentioned,
yeah.
that is of the GPT model, which is the which is a chat model of OpenAI.
Got it.
That has
Okay.
that has a shorter context length, and
Got it.
yeah, that's it. Okay. So now let's move on to the code. Let's view little code, and we'll come back here. Okay. So first of all, yeah. So first of all, we'll import to perform a semantic search. We'll basically be performing a semantic search here. So first of all, we'll import and install all the libraries. So we need OpenAI, which is our basic OpenAI. We'll include transformers. From transformers, we will be importing the tokenizer to measure the length of our text so that we don't send more than 8,000 tokens at once, right? So we have imported OpenAI. We have imported pandas. We have imported pandas to basically view our data frame, our database, whatever we have inside of Python. So we'll be manipulating our database using pandas and NumPy. And OpenAI provides us with its own cosine similarity function. So we'll be using that only. And from transformers, we have a tokenizer. And this basically provides us progress bars inside of Jupyter Notebook. Okay, so we'll run this. And we have set our OpenAI key and organization key. Now, first of all, let's see how an embedding looks like. We gave you an example in one of the slides. Okay, so we have we have taken the text as ROM. We have called the create function of the embedding class from OpenAI. We've used the ADA002 model, and we have stored the response of the call in a response variable. Okay, so we'll see how the response looks like. Okay, so this code will be returning a response like this. It is a JSON. It is a JSON value, and it contains all the embeddings. Yeah. Okay. So this will give us the list of embeddings. This will be, if we check the length, right? It will be 1536 floating point numbers, which OpenAI returns. Okay. And we can even pass a list of text to get all the embeddings.
Sorry,
And
what was your input to create the embedding?
our input can be any text. or it can be any list of text.
I see. It can be my custom data corpus
Yes,
for my
it
enterprise.
can
Huh? Okay.
it can be your column of data, and all of that will get processed here.
Okay.
Okay. So here I will create this. Yeah. So we'll see our data of 0 will give the embeddings for she is running. Data of 1 will give for fitness is good, and so on. Okay. So yeah.
So
Now,
these are specifically GPT embeddings. So I
yes.
could not probably take these GPT embeddings and use later on a different LLM like Alpaca or StabilityLLM, right? So that will not be correct because these are specifically GPT LLM. They are not portable to other LLMs. Am I right?
No, these are just embeddings. If so, these all embeddings will have dimensions of 1536, right? So if you can create embeddings using a different model and you can perform a vector search, you can do that anywhere. Now, what you mentioned, Alpaca and Llama and other LLMs, that would be fine tuning the data. So fine tuning can be performed there, but for semantic search, we are specifically using this GPT text embedding ADA model right now.
Okay. Okay.
Okay. So yeah, moving on to text similarity. Okay. So text similarity. Okay. So basically, we remember from a previous example, we told that Bangalore and lecture are far away, while Bangalore and Pune are closer because they are both places, right? So how exactly do we know that they are closer or far away? So that's what text similarity tells us. Basically, we perform a vector search or cosine similarity. So we'll talk more about cosine similarity in the further slide. So yeah, using that only we can perform text similarity between two pieces of texts or words or tokens or anything. Okay.
In order to calculate the distance between two vectors, we need the dot products of two vectors. So distance would be calculated as np dot product of vector 1 and vector 2. Can you move to the next slide?
Yeah.
Yeah. So here we see item 1 is another vector and item 2 is another vector. So in order to calculate the distance, I'll apply the cosine product, which is also known as dot product. So the distance would be calculated as cosine product or the dot product divided by the length of the vectors. But here, since the length is already normalized, so we just don't need to divide it by 1 or any of the length. So the degree of closeness is decided by the angle, the distance theta, which we have in the 2D curve. So we can use cosine distance or cosine similarity to calculate how close two data are or two texts are.
Okay.
Can you please move on to the code?
Yes. Okay.
So here we had a list of text which was she is running, which was EMB1. Now we have EMB2, which is fitness is good. So we'll see the text similarity of EMB1 and EMB2. She is running and fitness is good. Okay, so this was 0.81. Can we move on to the next thing? 2 and 4. We have fitness is good and basketball is healthy.
Yes.
Yeah. So here in the first embedding EMB1 and EMB2 gave me somewhat 0.81 percent of similarity, whereas the second one and fourth one, which was fitness is good and basketball is healthy, gave me 0.87. It would be because these two sentences, fitness is good and basketball is healthy, are somewhat related to fitness only, and there is no particular person we are referring to. We're just referring to a sports and to a matter of sports and health. Whereas in the first EMB1 and EMB2, we are talking about fitness, yes. We are talking about health, yes. But we are talking about a specific person, in one of the texts, and in the other text, we are talking about a generalized statement. So maybe because of that, we have less matching for the EMB1 and EMB2, and for EMB2 and EMB4, we have more results.
But I thought we will do cosine similarity score, but you are doing a dot product
Yes,
to
sir.
compare.
Because sir, everything is normalized. So if we do dot, if we find the dot product that tells me the angle between the two vectors, I mean the two embedded points in the space. So
So we
basically,
actually don't use cosine similarity then.
No.
we will, sir.
Okay, okay,
Yes.
okay.
Okay.
Okay, so we'll now start reading the database and we'll pre-process. So can you please move to the database we have? So we have chosen a database which basically has mental data. We have certain questions for depression and anxiety and corresponding answers with that. We have 98 rows of data and corresponding answers. The columns are question ID, corresponding questions, and the answers to the questions asked.
Okay. So we'll starting with the reading the database and pre-processing. So first we'll read the data using the pandas library that we imported before. This is our file name, which is mental health FAQ. And in this line, we'll be dropping the null column. So like say we don't have an answer for the specific question in our database. So we'll drop those columns, right? So now if you see, we have 98 entries. So all of them had answers. And these three are our columns. Okay. Let's look at a database inside our Python. Yeah. We have question ID, questions, and answers. Okay. So we'll create a combined column, which we will be using to convert it to vectors and performing a vector search. So our combined column will be title. We'll give the title to the questions field, and content will be our answers field, and they will be separated by a semicolon. Okay. Now, if you see our data frame, it
So
should.
what are these question and answer again?
Okay, so this is basically a database that we chose for semantic search.
Okay, okay.
This is a database on mental health FAQ. So
Got
basically,
it.
where can I find free or low cost counseling? So it has its answer. So after semantic search, we can ask it any question related to, if it is inside this database, the bot will be able to answer us.
So it could have been just freehand text. It need not be organized like a two columns like this, right? It could have been random text.
Yes, it could have
Correct?
been. It could have been just a single column of text if you wanted.
Okay, got it.
Yes. So now let's calculate the text lengths and bring everything under 8,000 tokens. Yeah, so this GPT-2 tokenizer we have included from Transformers, and this is the last one that OpenAI open source. So we'll be using this to convert. First, we'll load the tokenizer. Yeah. So now we'll create a n tokens column in our data frame, which will combine the number of tokens in our combined field. Okay. So we'll be applying on our combined field a function which will return length of the encoded text. So we'll do this, and yeah. And now we want to keep the only the columns which have a number of tokens less than 8,000, right? So we'll do this, and we'll see we have two new columns, combined and n tokens. If you see our database, n tokens, yeah. So number of tokens we have are 271, 246, and all of them would be less than 8,000.
Are you saying you discarded which had more than 8,000?
Yes. So like right now we have discarded which had more than 8,000, although there were none. But yeah, we have right now discarded. So it's better while collecting our data, or before performing the semantic search, it's better to collect the data in such a way that it won't have more than 8,000 tokens, because OpenAI has a limitation of 8,000 tokens, right?
So if it was a large paragraph, I could break it into chunks, right?
Yes, you could break it into chunks, and it would be vectorized in that sort. Yeah. So
No,
if we have a
okay.
book, we break it into separate paragraphs of 8,000 tokens, which are roughly 6,000 words,
Mhm.
and we process it like that only.
Right.
Okay.
So we'll now start with the embeddings. So here we have, because we are using text embedding ADA model. So here we'll call a function create from embedding class of OpenAI, and we've already decided the model, and whatever text we have given is the input. We have kept the batch size. We have kept the batch size as 2000 because it is a safe number for data which are which have many rows and columns. So because it takes lots of processing times and it has a limit, and OpenAI free open source has limitations. So we have kept the batch size as 2000. So in this, we are calling the embedding function again and again, and we are creating the embedding of the data set we have.
Okay. Yeah.
Now we'll see df.head.
So you are creating embedding of this entire Q&A data set.
Yes, and we are storing it in ADA vector.
Column. Yeah.
What
So,
was the combined thing? Combined is question plus answer, huh?
yes.
Yes, so the title and the context of the, suppose this is
Okay.
how do I deal with depression? So the possible ways of depression. So the answer and the question in the same column.
Got it. But won't you have to store this in some vector database like Pinecone?
Yes, sir. We did try Pinecone, but because it
So
was
actually, like we can use Pinecone for the purpose of this webinar. We'll be using this pandas itself, and Pinecone automatically performs cosine similarity on all its database. If you have a larger database, it's much better to go there. But right now we have 98 rows, and we can perform cosine similarity on each of these rows and get the answer there itself. So right now we'll do that.
And we are not using LangChain, right? That could have been one more way of workflow automation.
We are not using LangChain right now. We could have. Yeah.
Yeah, okay.
Okay.
so now we see df.info and we get to know what are the question IDs, what are the non-null values, and the data type, corresponding data type. And we have ADA vector, 98 non-null values for the same. We'll now be converting the ADA vector into, because it is already in the form of strings. Now we want to convert it in the form of vectors so that we can apply the cosine similarity. So we use this function, ADA vector dot progress apply eval, and then we basically convert this string into vectors.
And we'll be saving the once embeddings are created, we can save them to a CSV file, or we can upload them to Pinecone, as sir said, and so that we can use them for future querying and everything. Now, once text has been encoded, right, it has been converted to vectors, we can like save it, because unless the text changes, the vector won't change. So if we send the same text to OpenAI to create embeddings again and again, it will return the same set of floating point numbers, right? So we can save it and we can use it later also. Now we'll create a query.
So you have created basically embedding index.
Yes,
Index.
this
Okay.
is our index. We have stored the vectors, and we will now convert our query into an embedding of another set of 1536 floating point values, and we'll perform cosine similarity on that query and this AD vector and get the top results. I'll just show that. From We'll save this as a query. We'll see how our query response looks like from the get embeddings function. Remember, we created our get embeddings function before, which basically calls the create function of the embeddings class of OpenAI. So this query response should contain the embeddings to this how do I know text, right? We'll just see that. Yeah, it returns a JSON value which contains the embeddings. And we'll see this should contain just the list. Yeah. So this is a list of 1536 floating point values between -1 and 1. And we'll be performing cosine similarity or text similarity between this vector that we obtained and a column of ADA vector. Okay. So yeah, we'll save this in a search vector variable.
Moving on to now, as we've already saved the query embedding into search vector, we'll now apply cosine similarity in each of the row of our data. From the ADA vector, we'll find the cosine similarity of the query and the ADA vector of the particular row, and whichever matches, we'll keep that as similarity. We'll save that in the similarity column. So once we see df.head, we know from the query, whatever we have given the query, which is the best suitable match. As of now, we have just got the details of the similarity, the percentage of matching for each of the row. We'll then sort the value so that we get which is the most suitable. So that is why we have put ascending is equals to false, so that we get the most probable or the most similar text according to our query.
So we have sorted the values, and we now have a data frame which has the similarities sorted from in descending order. So we will save this similarity sorted data frame. We'll take its top three values. Dot head 3 will basically return these top three: 77, 74, and 30. These are the top matching, the closest answers to our query. So we'll be saving those three in the result variable. We'll see result. It should contain those 77, 74, and 30. Yeah.
I mean, why are we not getting close to 95% plus match? Because that question probably is well answered in that
This is
corpus.
this is just closeness. This is the okay. So in this figure, this is the cosine distance or cosine similarity. The angle theta represents the cosine distance or similarity between two vectors. So the less the theta, the closer the vectors are, right? So this is not the percentage of match between our query and the text in the database. This is
Okay.
just the similarity.
Okay.
So now further, let's move on. Yeah, so we'll be constructing a prompt for GPT. So why are we constructing a prompt for GPT? So we have our top three matches. Now we don't know, like the first one should be the should contain the answer to our query, but we don't know what part of it to return, right? We cannot just give our users the whole combined text. Okay, so what we'll do is we'll tell the OpenAI GPT model to we'll give it our query, and we'll give it these three combined texts, and we'll ask it if our query is contained in the above context, so it will reply accordingly. So this is the prompt. The header would be answer the question as truthfully as possible using the provided context, and if the answer is not contained, just say I don't know. We are adding this line if it is not contained within the text, say I don't know. We have added this line to basically to not allow hallucination. Okay, so if we don't add this line, the GPT response might hallucinate, and based on its previous patterns, it might return some rubbish answer. So we've added this line, and after, okay, so we'll be doing header plus context. Context will contain the three combined texts. These three, all three would go into context, and our query would be here after the Q, and after A we ask GPT to complete our answer, right? So we have constructed this function. Now let's see how a prompt might look like. So remember, our query here was how do I know if I'm suffering from depression? And XC is the list, is the result dot combined. This combined column converted to a list. Okay. Yes. All the three combined texts come here in title and content. This is our query. This is our answer. Okay. So we will be using the OpenAI's completion API. So we have given it temperature of 0.0 because it gives the most factual answer from like if it knows, then only it will give it. Another reason of temperature giving 0 is it reduces hallucination. We have given maximum tokens to 300, and we'll be using the text DaVinci's 003 model. Okay. Yeah. So we'll be calling the create function of the completion class of OpenAI, and the prompt will be given by the function that we defined before, the construct prompt function, which has the parameters as query and XC. XC was just our combined column converted to a list, and we have given the completion API parameters, right? So let's first see what our response looks like. Okay. So response is another JSON value. It has all the other information that OpenAI sends us as a response. We just need this text, which is our answer, right? So we'll do response dot choices, which will be this list, and we'll be doing 0, which will give us this dictionary, and we need the uh, text key of it from the dictionary. So this will give us our answer to the query. Yeah. Signs of depression may include feeling worthless or hopeless, and these are. So we this way we are sure by performing semantic search, we are sure that whatever query we have given will be answered from our given context only. So we are sure that this text or somewhat this text would be included in our database. So yeah, that was basically performing semantic search. Now,
So how are you sure of that? Sorry, I missed that one.
because we are not allowing it to like we are giving it temperature of 0, so it cannot temperature is basically its creativity level. We are not allowing it to answer on its own. we
Got
are
it.
we are telling it to say I don't know if it doesn't know the answer, and we have not
Hmm.
provided it with any other data. We have provided
Mm-hmm.
it with all this context from our database.
Okay, so don't try to guess. Be very, very precise.
Yes.
Okay.
If the answer is within this context, then only it will answer. Otherwise, it won't. It will say I don't know. Let's see that. Okay. So let's change our query. Just a second. Um, let's change our query equal to. I'll just run this function. Okay, I show that. It will return. I don't know if it doesn't know the answer in this chatbot. Okay, so we'll compile the above code into a chatbot. Okay, we'll enter the query. We'll convert the query to a search vector by using the get embeddings function, which returns the embeddings from the OpenAI's API. And we will be creating the similarities column again and again on different queries. Like right now I searched something, right? It created a similarities column based on that specific that specific query's embeddings. So every time a new query is given, it should create a different column, right? So we'll be again same code as above. We'll be performing the cosine similarity on each and every row of our ADA vector column, and we'll be storing that in the similarities column, and result will be the descending order of our similarities columns top 3 values. Okay. And we'll be performing the completion, calling the completion API of OpenAI to get our specific answer. Let's see how this works.
So for context, you are really getting 3 embeddings, but you are combining them or unioning them.
Yes, so
So to get the answer, you're trying to extract from top 3 embeddings, correct?
yes.
Or would you want to extract the answer from the top embedding, not the top 3 embeddings combined?
Yes, we can do that also. But I've chosen top 3 because see, these similarities were quite close, right? So the answer
Okay,
could be any one of them.
got it.
So
So power of the crowd. So you're using 3
yeah,
for
top 3
that
we'll
purpose.
use. We can use top 5 or anything. Okay. So okay, tell any query I'll type.
So just Prasanna here. As I just
Yeah.
instead of this embedding space that we are creating, and from there we are finding the top. Is it mandatory to do it, or this question that we have, with the temperature 0, if we can directly provide that information to the API, OpenAI API, and we will be able to get it right. What is the purpose of creating this cosine similarities and get the top 3 and all those things? Probably I'm missing something.
Yeah. So we have our data set here, right? So are you okay? I'll just repeat your question. Tell me if I got it right. So you're saying we can just provide the completions API all this database and ask it our query. Is that it?
No, see first the cosine similarities. What is the purpose of getting the cosine similarity? So these are fixed queries or questionnaires. Only this that it will understand, or your question is very clear, right? Your question is in terms of what is the reason for the depression. So that is the one, and specific to that query, you are finding the similarities, right, from the
Yes.
database, right?
Yes. Yes.
And then from this database, the similarity items as an embedding that you are sending it to the OpenAI, and you are getting the response. Is that the understanding correct?
Yes. We are converting the all these questions and answers to embeddings and then performing a semantic search.
That is
So
in the local.
Prasanna,
Yeah.
let me step in here. So we should ignore the fact that this corpus is in form of question and answer. So let's assume this is a book. Let's assume this is a healthcare book,
Okay.
right, or a manual. So it is free form text. So we should ignore the fact it's question and answer. This
Okay.
could be a free form text. It could be a book, a manual, or for a technical healthcare paper. So what we have to do is, the problem is you cannot pass the entire book as context to ChatGPT or GPT because it's too big. So what you do, you break the book into chunks, 8,000 token chunks.
Okay.
And then for each chunk, you create a sort of a embedding, and then you try to find the top 3 chunks in the book where my final question's answer may lie. That's what we
Got
are essentially doing. So first we narrow the 3 chunks we may want to arrive at, rather than trying to find the answer directly in the entire book.
Perfect. I think now I got it. Yeah. Go on, please. Yeah.
Yeah.
Thank you. Okay. So yeah, let's ask some questions.
Ask how do I become famous?
How do I become famous? Now, let's evaluate what it will do. It will save the query first. Okay. It will convert the query to search. It will create a vector from the query, and it will perform similarity, a cosine similarity on each of the vectors that we have in our ADA vector. And in my understanding, this should return, I don't know, because it's a mental health FAQ dataset, right? So it should not contain this. Yes. Now we can try another query.
I am a teenager. How do I deal with anxiety?
Yes. So as you can see, it is able to answer us correctly. Like, this was a question related with mental health. It was included somewhere in a database. The answer to this was included. So we were able to extract that answer from our database.
So this answer might span the three embeddings you zeroed in on. It need not be all be contained in one embedding or one Q&A in your case, correct? So this
Yes.
could be a combined answer from the three embeddings.
Yes.
Yes, sir.
Okay.
So now, the question is, why we need to, because you already have identified the three embeddings, and it is only the summarization that is required. Only for the summarization, we are going to the OpenAI API
ChatGPT.
or ChatGPT.
No, not exactly summarization. So
Okay.
let's say we have any question, right? What is the difference between anxiety and anxiety disorder? So its answer will contain information about both anxiety and anxiety disorder. So basically, one specific, like, uh, let's come here. We have this, right? Title. Okay. This may contain the answer to our query and much more information. So we need to extract the answer to our query from all this context that we have received, right? So that's what we expect from GPT API to return.
So effectively, the summarization is that.
No. It's not
Not
summarizing. It is generating new text based on its understanding from this complete text.
Okay.
It's generating new text based on its understanding from this entire text. It's not exactly summarization. Because
Okay.
summarization, Prasanna, will have lot more stuff which this overall text addresses. But
Okay.
my answer, which got generated, is really precise to my question. It is a smaller part of this overall information.
Got it. Yeah. Got it. Yeah.
there might be a lot of extra information in this piece of text only, but there might be more useful information too. Okay, so we need just the useful part. So we ask OpenAI to extract information from this. Yeah.
Yeah, in fact, if we set temperature to a higher value like 1 or 2, not 0, we could allow it to be even more creative. So, but the problem is if you allow it to be more creative, then at some point it may start hallucinating or giving answers which are kind of absurd. So it's a balancing between creativity versus strict control.
Yes. Okay. So let's give this like we have created a chatbot in Python. Let's
Okay, let me give you a question.
okay.
So
Wait, I'll run this again. Yeah.
yeah, so uh, you know, let's say mental health is an epidemic, right? Mental health issues are an epidemic as big as infectious disease. So how can it be fixed?
Let's see. Okay. So it took our words literally, and it says it's not a disease, but it can be improved through developing well-being, resilience, and seeking help. So,
Okay, yeah.
like right now, we just have 98 rows, right? So, the quality of answers and everything actually depends on the quality of data and the amount of data that we have. That will vary.
So if I feed it, let's say, hundreds of thousands of literature in healthcare, it could create a very accurate Q&A bot, right?
Yes.
Yes, sir.
Yes. Exactly.
So now here, one other question is the API calls basically depend on the temperature that you are using and the number of tokens. So you get charged. And is there a way that we can have this like an offline mode of execution without using OpenAI's API and bring in the similar kind of an output? Have you guys tried anything similar?
Okay. We can do that. So right now we are using OpenAI. We are depending on OpenAI to get the embeddings and for this completion API, right? So we can instead of using OpenAI, we can use sentence transformers. That's another library to generate text embeddings. And instead of GPT or DaVinci model, we can use any open source large language models which are present, like we have that Dolly. We have
Dolly to
Dolly.
Stability LLM. Yeah.
We can use any open source LLMs too, and it could be turned into free offline mode. But OpenAI has the best text generation models and embedding models, so that's the reason we have used that here.
So Prasanna, research suggests that GPT and ChatGPT is far ahead in sophistication compared to all other models from let's say Alpaca Llama from Facebook, or Stability LLM, or Dolly 2 from Databricks. Or
Okay.
GPT is far ahead, and all others are more of experimental technology and doesn't come close in sophistication.
Got it, Vivek. Yeah, thanks.
Google Bard, I don't know. I think Google would try very hard to catch up, but so
Yep.
far they are still behind in terms of sophisticated LLM.
Yeah.
Got it. Yeah.
Okay, so let's give this a face. Let's give this a simple Gradio UI. Gradio is basically a platform where it's a framework from Hugging Face, and you can host your ML models on Gradio, which others can also use. So first we'll install the important libraries that we need. OpenAI for embeddings and that completions model. Transformers for tokenizing, for calculating the length of the tokens, and Gradio, which is we'll be working on. So this all importing is mostly the same. We're just adding this import Gradio as GR, which wasn't there in our previous notebook. And yeah, we'll be okay. So we'll be first of all defining the basic parameters and functions. And this is the same params that we used before. We define the get embeddings function. This was also there in the previous notebook. And similarly, the construct prompt too. Okay. So yeah, so we'll create a function first of all to process the CSV file and save a CSV with the embeddings. Now we save the CSV so that we can further use it if we want to, right? So again, loading the CSV file from file.name. This is the file that Gradio will send us in whenever the function is called. Okay, we'll drop the null values. This line I added to reduce the time taken by OpenAI to create the embeddings, but if you have a large data set, so 1 lakh rows that I tried, it was taking around 10-15 minutes to return the embeddings of 1 lakh rows. So we can remove this. We can embed any number of rows using OpenAI. We'll be charged accordingly, obviously. Okay. So our CSV file can contain any number of columns. Like right now, we knew the column names were questions and answers. So what we can do is we can combine all the columns if we don't know what exactly is in those what all columns we have, right? So that's what we do here. We combine the column names into a variable called column names. We create a combined column in a data frame with title and all the column names joined together. So basically, we combine all the columns, all the data of all the columns in a particular row, and place that in a combined column. Okay. And we remove the trailing white spaces, which take up just extra space. And then we convert again the same. We convert the combined column into a number of tokens, and we store the length of tokens in another column, so that we can remove the columns which have greater than 8,000 tokens. That we do here. Now, batch size, as we mentioned before, we take the batch size of 2,000 because it was a safe number to perform this get embeddings from the OpenAI API, and we place all the embeddings in our ADA vector column. Okay. So now we drop the null values, we save our data frame to a CSV for further usage, and we convert the ADA vector, which is currently a string, to vectors, so that we can perform text similarity and everything. So this is a function, create and save, right? So next we have our semantic search function. Semantic search, in this function we'll get the embeddings of our query, okay, and we'll apply cosine similarity between that search vector and all the rows of our ADA vector, and we'll save that to the similarities column, same as before. And we'll take the top 3 similarities after in descending order, and we'll store that to result variable. We'll convert the 3 results into a list, and we'll call the OpenAI completions API, and we'll return the text that we receive, right? Now, Gradio setup. So in Gradio setup, we have provided 2 inputs and 1 output. Sorry. One of the input is the CSV file. So gradio.inputs.file, and this will take our CSV file as an input. It could be any CSV file right now. Okay. Sorry. We have a text box input for our query, and we have an answers output, which is again a text box, which will return the answers to our query after all the processing that we have done above, right? So here I'll just tell you what will happen in a second. So Gradio in the interface, in this we have to provide the starting function. So our function will be process CSV and search, and inputs are CSV input, query input, and outputs are answer output. Okay. So now what's happening here? So basically, what we thought was, when we create an app, right? So if we upload our CSV file once, we don't want the embeddings to be created every time we enter a new query. So we have given df equal to none. It is just a placeholder for the process data frame. Okay. So in this function, if df is none, so like when the first time when we are uploading our data frame, right? So if df is none, it will create and save that embeddings. Okay. And answer will be stored in semantic search of df and query. Query was whichever we give, and we'll return the answer. Now, when the next time when we enter a new query, right? So our df is not none. Df will be containing our processed data frame, which will be used to perform semantic search. Okay, let's run this. Let's see how it works. And I've done share it equal to true. You all can try with your own CSV files if you have. Just a second. It is loading now. Yeah, it's loading. So I upload the same. Wait.
No, what do you mean by CSV file? That Q&A healthcare file, huh?
Yes, this is a CSV file. CSV basically means comma separated values, and
Can't I have a free-form text file, PDF?
not in the current setup, no. But we can change the function to like to accept other types of files too. Like right now, I've set it to be CSV, but
Okay.
we can edit the code however we want.
Mhm.
Okay. Just a second. Just a second. I'll pause my screen share. What I'll do is I'll send the link in the chat, and I'll send this link in the chat, and you can try this if you have some CSV files and some queries. Yeah. So give me a second.
Can this Gradio client will continue to be active, or you'll decommission it after this workshop?
After this workshop, as soon as I stop this cell from running, it will stop. But the same code could be combined into a single app.py file, and it could be hosted on Hugging Face.
Yeah, we want to have a client like this going on CellStrat Hub, right? So,
Yes.
okay, we'll talk about that later.
Okay. Sure. So I'll show you. Okay, I downloaded the mental health FAQ file. This one. So once this is uploaded, I can search anything. Suggest a query. Anyone?
No, you just uploaded it, so it would have created the embeddings already?
Not yet. I'll give it as soon as I submit. The first time I submit, it will create and save the embeddings. But after that, it won't create again and again.
Got it.
Okay,
So how do you take care of moles, MOLES, moles?
What do you mean by moles?
You know that mole, you don't know what is a mole? This happens on human body.
I'm not sure what you
In
mean.
Hindi, we call it a till. Till.
Huh? Yes, yes. I know till.
So in English, we call it a mole. So how do you take care of moles? It's a healthcare question.
What do you mean? I didn't get you.
Or how do you treat a mole? How do you treat a mole?
The question is for the chatbot.
Acha.
Yeah, obviously, Kanwa. You're not a dermatologist, so I'll ask that.
Okay. Okay.
So,
I submitted it. It will process and save. Yeah. So
okay, not found. Okay.
it will return. I don't know.
It created embeddings very fast. Yeah.
Yeah, it's just 98 rows. So
Okay.
the OpenAI API is quite fast. So
Okay.
will return. If it is, I tried it with 1 lakh lines of data too. So that took about 12 minutes to create all the embeddings.
Okay.
It is pretty fast.
Nice. Anybody has a question, a healthcare question they want to ask? Okay, let me give you a confusing question.
Okay.
Uh,
Let's see.
should I invest in medical shares, a medical company shares. It's a financial question, but for healthcare companies.
Say I don't know. Yeah.
Okay, clear.
Let's say healthcare.
Okay, that's correct. Okay, how to lose weight fast? A generic question. How to lose weight fast?
It still says, see, that's the thing. We are providing ChatGPT, the completions API with our context. So even if I ask it, let's say, who is Virat Kohli, it should still say, I don't know, because it's not anywhere in our context, right?
Got it.
Okay. So, is anyone testing with their with this thing, or should I stop it?
Can you try one more question?
Sure.
Like, how do I know if I'm sick? Can you try?
How do I?
That means all answer depend on the file, that mental health,
Yes.
whatever. So
The type of
unless,
answer. If I want, I'll try mentally ill. This should give answer. So it depends on the quality of data, basically.
So if we increase the temperature, say to 1, do we get different response?
We should get some different response, and it also depends on our prompt, right? We are prompting it that it should say I don't know whenever it doesn't know an answer. Whenever it is not contained within the text below, it will say I don't know. So even on increasing the temperature, it should say I don't know also. We can try it. We'll do that.
Okay, is there a way that I got it? Is there a way that, in case if the given context is not covered, is there a way that we can ask the system to actually find it from the general knowledge rather than looking for specific context?
Yes, that defeats the purpose of performing semantic search, right? Like semantic search is basically when we specifically need an answer from our given data source. So if you are asking it to generate answers on its own, then the whole purpose is gone.
Got it. Yeah.
Hi guys, this is Sujit.
Right.
So Bhatia, I have a question. Okay. So basically we are using this bot for the only question and answers which we have. So it will only tell or give anything between those question and answers, right?
Yes. So within our context, yeah.
Yeah. So I think we can try it in a different manner also. I mean, providing all the context which have, instead of you telling it answer the question which are given in the data set, you can thoda genderify it and say ki, this is the context, so answer among this matlab. So it will try to summarize things throughout those whatever data source you have. So it might link 2 or 3 or 4 5 questions, and then it might answer those things.
So you are saying, should we increase the like instead of top 3, should we take top 5 and change our prompt somewhat like this is the context and answer is contained in this context, and it should answer like that?
So that's how it will become thoda creative and try to understand the context, and then maybe give a generic solution based on all the question and answers which are in the context, instead of specifically saying it if it's not present in our question and answer database, don't give any answer. This is like a straightforward bot. You are telling it ki these are the question and answers, answer only into this thing. So that can also be done in normal these cases, but we
No,
can
no,
actually
Sujit, you can. This will work fine even if you remove Q&A as a source. Just think of just a book there.
Yeah.
It will work even with a book.
Exactly, in the book case also it will work.
Yes, it will work. So
Yeah.
that it just so happens that his data set is Q&A, but it could be
Yeah.
as well be a paper, a newspaper article. It could be a book.
Exactly.
Even then
So
it will work.
that's what thoda, if you change the system, this thing, and tell it take this as context and try to answer within the context. Thoda
that-
generic. Yeah.
So the prompt could be changed however we want as the application that we want. So currently it's Q&A. So I've instructed it to perform Q&A and answer. I don't know whenever it is not in the context. So we can construct the prompt however we want. Yeah.
So you have written here now. Just scroll through the system prompt to the right side a little bit. If the answer is not contained within the text below, that means it will exactly look for that question ka answer.
Yes.
That's what I was. Yeah.
No,
So,
Sujit, I think there is still some, a difference here in understanding. So it is not just answering the precise question which is there in that Q&A. It is actually
Okay.
generating new answer based on the top 3 matches. So it doesn't mean that it is actually answering only if that question is matching one of the top 3 questions. Not at all.
Okay.
It is actually generating text from 3 paragraphs. So, and if the question I am asking need not be precisely the question in the Q&A database.
It may or may not be like those same exact words may not be present in the database, but the completion API changes the text. Yeah.
Yeah, that I understood.
Okay. And anything else? Okay, so let's look at fine tuning 2 ones. So I took this same data set and I So this is the prepared dataset that OpenAI requires. It is in the form of prompt and completion. Okay, this is the same dataset, but just prompt before the questions thing and completion before the answers. Okay, so I fine-tuned a model to show the difference between how a semantic search would answer and how a fine-tuned model would answer.
So here we have imported the OpenAI, and then we are using API key as usual. Now here the file which we are using is already the prepared JSON file. So we are using the create function from the file class of OpenAI, and we are identifying the purpose as fine tuning. So using this cell, on running this cell, we'll get a file ID. We'll use this file ID and we will put this into the training file and we will use the model DaVinci. So we'll first fine tune this.
Yes, so I've already fine-tuned it before. It takes time. Yeah.
So we have a JSON output which has the events, then it has ID. It has the ID of the file which we've used. It has the list of the JSON file. It contains events, bytes, and then the particular data type. Then we retrieve this file from the file ID.
Fine-tune ID, yes. So we can see how much it cost us and everything. Yeah, continue.
Yeah. So can you please move to the next slide?
How many rows have you fine-tuned? I mean, how many prompts and all?
All 98.
98.
Yes.
So here.
So what do we mean by fine-tuning precisely here? I know incremental machine learning, transfer learning in the neural network sense. What do we mean by the word fine-tuning here? Are you saying those Q&A are acting as additional sort of data to customize GPT? What is actually fine-tuning doing? In neural network, we know transfer learning. We train the final layer again with our custom data, right? What are we doing here?
So this fine tuning is already a type of transfer learning. We are just telling them, training the model to perform a new task instead of giving a new information. We are not doing any changes in the information. We have already prepared a JSON file on mental data, and we are just asking to perform a task which is identifying the depression or solving our query. So it's just the new task which we are training our model on. So basic layer, the prepared data remains the same. It's just the neural networks which will change, which will identify the relationships between the questions and the answers, and it will give us suitable results for that.
So here you are training it with that Q&A healthcare database you showed.
Yes, yes.
So that's called an instruct database, right?
Yes.
So for that question, that's the answer, correct?
Yes.
So in a way, it's analogous to incremental machine learning on a neural network.
Somewhat.
Somewhat, because here we freeze the lower layers so that those lower layers remain untouched, and we just train the model on the upper layers. So
Correct.
As like in this prepared data set, we have a different set of prompt and completion. So this basically acts as a new task. Like we tell the model, if this is the prompt, it should complete.
This is the answer. Okay.
Yes. So, but again, that's the difference with fine tuning. It may or may not do this every time. Yeah. Here.
okay. So in the function, we have given the query, how do I know if I'm depressed? So in the response, we are using the create function from the completion class of OpenAI, and the model we have used is DaVinci. Now here the temperature we have kept to 0.89, which sets the creativity level as we know. Max tokens is the number of maximum tokens the prompt can generate, the query, the response can generate. The top P column will specify, basically top P is a cumulative distribution function. Suppose if in a data, I have the occurrence of carrots as 2%, I have occurrence of cucumbers as 1.5%. If I set, suppose if for carrots it's 1% and for cucumbers it's 1.5%. So if I set top P equals to 1, so once I enter, suppose I want to eat. So for 1%, for top P equals to 1, it will give me carrots. If I want to put 3%, so it will cumulate 1, which was 1% of carrots and 1.5% of cucumbers, and it will give me both as the results. It will give me the range in between carrots and cucumbers. So this is the function of top P. Then is the frequency penalty, which will tell me, which tells us, which reduces the frequency of particular words which have already been generated. Suppose if I already have depression 2 times, so the probability of depression coming third time would be relatively less. If we set the frequency penalty to somewhat 0.6%, accordingly it will vary. So here we have set it to 0. Then is the presence penalty, which gives me, which gives us the novel answer. It corresponds to somewhat real answers, which is possible in the real world, so that the model does not hallucinate so much that it gives us imaginary solutions for the query we have. So now we generate the result.
Kanika, sorry. I
Ranjita.
have a small this thing. One observation when I was going through the OpenAI documentation. So they only generally ask us to use either the temperature or the top P, because both are somewhat similar itself.
Yeah, because
So
both are used. Yeah, sorry. Yeah, so temperature is also used for creativity. Frequency, top P is used for the like distribute. It is because of it is a distribution sample. No, so I can have, if the top P is 1, so I can have my range from 0% to 1%. That is what it means. Temperature is its own creativeness. Like how does it formulate the answers from the data we have given? So that is why that is the main difference between the temperature and top P. More are somewhat similar because both are used for random sampling. But here in top P, we can have a range. Rather than cumulating, we have set it to 1%. So if carrots are 1%, so it will give me only carrots.
So what if I gave book as a context? I didn't have a Q&A. I want to fine tune on a book. How would I go about it?
Fine tuning on a book. So OpenAI requires this data set has to be prepared in this form only, prompt and completion. So
Okay, so I have to create this
yes,
data set from a book.
but, convert that whole book context into a set of prompt and completions.
Got it.
Then OpenAI will be able to fine tune.
Got it. I mean, this is also fine, right? I mean, semantic similarity was fine. This is also fine. Or which one is better?
It depends on the use case, right? If we want a generalized chatbot which can focus on a specific set of data, like the last layer will somewhat have this data. So so then we can use fine tuning when we also wanted to know about all the general answers, like who is Virat Kohli and everything. Then we can use this. But if we want to create a bot, say on a code documentation chat, so then we don't want it to hallucinate anywhere else. Like we don't want it to answer on a specific function from some other library or some other function or some other language, right? If we are training it on Python, then it should answer from Python documentation only. So that in that sense, semantic search would be better.
So semantic search will narrow it to my data corpus, whereas
Yes.
fine tuning will also allow me to use ChatGPT in a generalized way.
Yes.
Okay.
For basic Q&A, basically, semantic search is more preferred if it is from a set of custom corpus. Yeah.
And one more thing. If your context is very large to be given in only one this thing also, so in that case also you should fine tune your model, because it will have the whole your data set has a context. So if you're unable to find the similarity search and put it into the same completion this thing prompt itself, then you should also go for the fine tuning.
No. In that case also, if we have a very large data set, say 10 lakh rows or whatever, in that case also semantic search should perform better than fine tuning, because if we have so large data set, first of all, fine tuning would be very expensive, right? And other than that, semantic search would perform better in case of Q&A from that data set. See, here we have, if you remember, we created a similarities column for every query we put, right? So if the data set is very large, the processing for that similarities column would take some time. But this is overcome by using online cloud vector databases like Pinecone. So Pinecone doesn't take that long to process all the similarities and everything. It can directly perform a vector search and return the answers in an instant. So if you have a very large data set, we upload the ADA vectors column to Pinecone, and yeah, basically that.
Yeah. One more observation from my this thing is key. So when even I use the vector databases for querying and all those things. So whenever I get the similarities and all those things, how much ever I do, my context for the question was not enough for it. So because I was reaching the max limit tokens and all those things, so the context, even though I generated from the similarities, because for answering that question it needed more context, so that was failing. So that's why in those cases also it's better to fine tune the model.
In those cases, I think we can first of all ask.
There is a limit for this thing, right? You can't put
API has
as
a
much of
limit.
Yeah. So but
Yeah.
if you fine tune it, it will have the whole context, and then also it can perform it. But this was from my use case which I was building.
No, let's say I'm a drug discovery company. So I have, let's say, 1 million pharmaceutical literature and Kanjiga. So I have 1 million pharmaceutical literature. I'm a drug discovery company. So I can do semantic search. But the problem with semantic search is it will limit the intelligence I get from the 1 million document corpus I have. But I want the overall ChatGPT intelligence also to be available. So in which case I
Not
have to
only, yeah, not only to that 1 million. Let's say you ask a question. Now the similarity search will only get the, let's say, top 3 or top 10. But what if for answering that question, it might require top 20 or top 40 or something like that, if the question is so complex.
Right. So I wanted to have access to the broader intelligence also, not just my custom corpus. In which case, fine tuning is the only option, isn't it?
Yes, something like that.
Yes.
So it's very, very contextual to the use case. If you want to
Use case.
narrow it to your custom corpus, you can do semantic search. If you want broad internet intelligence, then you have to fine tune.
Right.
Okay.
Okay. So, any other questions?
Audience, any other questions? So excellent presentation, Kanjika. Well done. Very advanced topic, which is very hot nowadays. Thank you so much. Thank you all for joining. Excellent
Thank
session
you.
by Kanju
Vivek,
and Kanjika. Yeah.
even I have, so I was also working on small similar kind of product. If time permits, I can just show it in just 5 or 10 minutes if everyone is okay with it.
Yes, absolutely.
Yeah, sure.
Okay, let
Is it
me.
okay, Vivek?
Yeah, just a moment. One sec.